big lavatory. It was about 24 feet or so in length, and I pushed off with my hand to travel across the module there. Guess what happened? When I push off with my hand, that was too much force to move this body that weighed nothing, and I went slamming into the other side. So you might have seen astronauts when we're in space. They'll show cameras, and you notice how slow we're moving. People think that we're moving because microgravity somehow slows us down. The reason why we're moving slow is because any exaggerated movement has to be compensated. So, for example, if I'm sitting in the middle of the cabin, and I decide to reach over and get my checklist that's on the wall, if I take my hand and do like that to grab, like I would here, and grab it, guess what would happen to my body? No, I wouldn't grab it before I got there. Say I was reaching for it, and I just did like that. My body would follow my hand because it's following the mass, and so my mass will shift over. So then I'll have to hold myself steady in order to grab the checklist and then be able to do it. If we're doing any switches, if I tried to do a switch by just pressing on a switch like that, the switch will not press. Guess who would move? Me. It's kind of a loaded question, right? So even a switch that would be really easy, like a light switch over here, we don't really have a light switch over here, but normal light switch, in order for me to do that light switch, I have to anchor myself first and then do the light switch. Or do what we do in our shuttle. If you ever go inside of the shuttle, all our switches have what's called switch guards, where we can hook our finger and then do the switch. So we hold ourselves in place and do the switch. More than you want to know. So the first thing I wanted to do when I got into space was to get out of my seatbelt and go and see the Earth. And what I saw was incredibly beautiful out the window. This big blue ball with these swirls of white clouds. And why is this blue ball? Why am I talking about blue ball? Why is that?
Because the Earth is mostly water.
Yeah, mostly water, around 70 to 75% water. So people don't realize, since we live on land, that there is very little land on the Earth. It's mostly water. So anytime we go out to look out the window and look down, chances are we're going to be looking at an ocean or something. And then occasionally you'll get a continent or two that'll show up, and usually it's covered with clouds. And so, but it's a beautiful, beautiful view. And then behind that is this sea of stars called the Milky Way galaxy, which is kind of cool. So it's pretty neat. So I mentioned to you already that I flew my first mission. We were up for 2 weeks on board Columbia. We did 91 different investigations. I flew my second mission on Discovery, and we did something kind of neat. We went to the Russian space station. The Russian space station had been up for about 13 years at that point. So as we got closer to the station, you could see in the solar panels and in its radiators, there were big gaping holes in it. Where do you think those holes came from? Think they were shot at by aliens?
Meteors?
Wait a minute, let me get somebody who hadn't.
Meteors?
Meteors, yeah. So when we're in space, we get bombarded every day with meteors that come from outside of our solar system. And some are really tiny, and some are fairly large. One of the holes I saw in the solar array was about that big. And that hole was probably made by something that was the size of $50. But because it was traveling so fast, when it hit the solar panel, it basically exploded. So we got to do a survey of the exterior of the vehicle, and then I also got a chance to do a spacewalk. So just because you go outside doesn't mean you're not going to be, safe against meteors. When we go outside, we are hit by meteors constantly. When we bring the shuttle back, we actually pick out small bits of meteors out of the shuttle tile and out of the material. So when we do a spacewalk, that suit that we wear, called the EVA suit, extravehicular activity suit, has to be strong enough to withstand meteors. Now, the one that I described earlier, that's the size of $50, if that hits us, it'll go right through the suit and right through me. We can usually track those somewhat because they usually come in conjunction with larger ones. And if there is any evidence of like a meteor shower, we'll actually move the orbit of the vehicle will come